For today's discussion, you will learn about solving problems involving permutations. At the end of the discussions, I hope that you will learn about analyze each word problem to identify the needed data, solve problems involving linear permutations, and permutations with identical objects. Let us apply what we have learned about permutations. First is the linear permutations. Example number 1, problem solving. In the class of Miss Lopez, suppose there will be an election. In how many ways can a president, a treasurer, and secretary be chosen among 7 candidates? Let us recall what is a permutation. Permutations as n distinct objects taken are at a time. So n refers to the number of objects from which the permutation is formed, and r refers to the number of objects used to form the permutation. In this problem, we will use the formula for permutations. So we have here given n, which is 7 for the 7 candidates, and for the value of r is 3. This is from president, treasurer, and secretary. We all know that the value of n is always greater than the value of r. So let us now use the formula of permutation, which is permutation of n and r. Next is to substitute the value of n to 7 and r to 3. Let us now simplify, so this will become 7 multiplied by 6 multiplied by 5. So 7 multiplied by 6 is 42, multiplied by 5 is equal to 210 ways. It is problem solving, so always put the label. So that is our answer for problem solving number 1. So are you ready for our next example? Okay. Let us now move on to problem solving number 2. The difference between US and the Philippine zip code is that the US zip code comprises 5 digits. Assume we use the 5 digits zip code of a place in the US. How many different zip codes can be made with the digits 0 to 9? If no digit is used more than once and the first is not 0. So I want you to take note of the digits 0 to 9. And no digit is used more than once and the first is not 0. So the given, for the first position, there are 9 possible choices, since 0 is not allowed. So from digits 0 to 9, we will start at numbers 1 to 9. So the value of n is, of course, 9, and the value of r is 4. So let us now use the formula of permutation, but we have to insert here 9. So 9 multiplied by permutation of n and r. So let us first copy 9 and then substitute the value of permutation of n and r. The value of n is 9 and the value of r is 4. So let us now simplify, copy 9, and then for the permutation of 9 and 4, so this is 9 multiplied by 8, multiplied by 7, and multiplied by 6. Now, this time, I want you to get the product of 9 multiplied by 9, multiplied by 8, multiplied by 7, and multiplied by 6. Okay, so let us check if your answer is correct. So the final answer is 27,216 ways. I hope you got the correct answer. Very good! You got the correct answer. from our example number 2. This time, I am sure that you can get also the correct answer. So listen to our example number 3. How many four-letter words can be formed from the letters in this word? The word is life. So our given here is n is equal to 4 because of the word life. We have here 1 for the letter L, 2 for letter I, 3 for letter F, and 4 for letter E. And we got the value of R is equal to 4 because of these 4-letter words. Next is to use the formula of permutation, which is permutation of N and R. Next is to substitute the value of N to 4 and also the value of R is equal to 4. Now, I want you to compute for the final answer. Okay, so let us see if you get the correct answer. So, permutation of 4 and 4, so we have here 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24, multiplied by 1 is 24. Correct! The final answer is 24 ways. Good job! Are you excited for our next example? So here it is our example number 4. How many four-letter words can be formed from the letters in this word? The word is charnal. So the given here is n is equal to 7. We got 7 from the word charnal. It is composed of 7 letters. And the value of R, we got it from 4-letter words. So let us now use the formula of permutation, which is permutation of N and R. So just substitute the given values of P of 7 and 4. Simplify, this will become 7 multiplied by 6, multiplied by 5, and multiplied by 4. So now I want you to get the product. Let us check if you got the correct answer. So again, 7 times 6 times 5 times 4. So the answer is correct, 840 ways. Very good, you got the correct answer. Next, with linear permutation is the permutations with identical object. Permutation with indistinguishable items, the number of permutations of n objects, of which A are alike, B are alike, C are alike, and so on. So we have here the formula, permutation is equal to n factorial over A factorial multiplied by B factorial multiplied by C factorial, and so on. Let us now have the problem solving about permutations with identical object. Example number 1. How many different ways can the letters of Mankatos be arranged? So we can now use the formula of permutation is equal to n factorial over A factorial multiplied by B factorial multiplied by C factorial, and so on. This time, the value of n is 9 factorial because we have here the word Mankatos and it is composed of 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9 over 2 factorial. You can also see here that letter A is written twice. 1 and 2. We have here 2 letter A. So this is 2 factorial. We can now substitute the given or simplify. For 9 factorial, we have here 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 multiplied by 1. It is division. We can cancel here 2, same with 2 with the denominator, and also 1 from our numerator and from our denominator. So the only numbers remain is 9 times 8 times 7 times 6 times 5 times 4 and times 3. So I want you to get the product. Let us check if you get the correct answer. Correct. The answer is 181,440 ways. Good job! For our next example, how many different ways can the letters of Magalang be arranged? Using our formula, P is equal to n factorial over a factorial multiplied by b factorial multiplied by c factorial and so on. Let us now substitute the given. So for n factorial, it is 8 factorial. From the word Magalang, it is composed of 8 letters. 1, 2, 3, 4, 5, 6, 7, and 8. And for our denominator, 3 factorial, as you can notice, we have here 3 letter A. So this is for the 3 factorial. And for 2 factorial, you can also notice here that we have here 2 letter G. So let us now simplify. For our numerator, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 L over our denominator 3 factorial. So we have here 3 times 2 times 1, and for our 2 factorial, it is 2 multiplied by 1. It is division, so we can cancel because the numbers 3, 2, 1 is same with our denominator. So the only numbers that remain is 8 times 7 times 6 times 5 times 4 over 2 times 1. So I will allow you to compute for our answer. Let us check if you got the correct answer. So the answer is 6,720 divided by 2. And the final answer is 3,360 ways. Good job! We are done with the permutations with identical object. Next is arrangements with restrictions. Example A. How many arrangements of the letters of the word poetry are possible if there are no restrictions? Use the formula of permutation of n and r. So let us now substitute the value of n, which is 6, because the word poetry has 6 letters. And the value of r is 6 because of the word no restrictions. So the value of r is equal to the value of n. And You can see here that we have here the value of n is equal or same with the value of r. So this is also equal to 6 factorial. So let us simplify. So this will become 6 times 5 and the answer multiplied by 4. Your answer multiplied by 3 and then multiply by 2 and multiply by 1. Correct. There are 720 arrangements. Example letter B. How many arrangements of the letters of the word poetry are possible if they begin with PO? So I have here an illustration. It composed of 6 rows because of the word poetry composed of 6 letters. So I write here letter P and O because it is indicated in our problem that they begin with PO. You can see here that we have here 4 spaces or blanks. So permutation of N and R, we can now have permutation of 4 and 4. The value of N and R is the same. So this is also equal to 4 factorial. Now, I want you to compute for our answer. Let us check. So this is 4 times 3 times 2 times 1. And the answer is correct. Very good. 24 arrangements. Good job. Before I proceed to our next example, I hope that you still remember our example for letter A and letter B because it is related to our next example. How many arrangements of the letters of the word poetry are possible if they do not begin with PO? So in letter B, the question is if they begin with PO. This time, the question is if they do not begin with PO. So we have here total minus the answer in letter B. So let us recall our answer for letter A. We have here the 6 factorial because of the word poetry composed of 6 letters. So the answer is 720. And for letter B, we have here 4 factorial. The answer is 24 arrangements. So we just have to subtract 720 to 24. So again, permutation of 6 and 6 minus permutation of 4 and 4. So this is equal to 6 factorial subtract 2 4 factorial. So the answer is 720 minus 24. Correct. Very good. 696 arrangements. Let us now move on to example letter D. How many arrangements of the letters of the word poetry are possible if they have PO together in order? So I have here an illustration wherein you can see here that I have only 1, 2, 3, 4, 5 rows because I write the letters P and O together in one row. So let us now use the formula of permutation, which is P of N and R. This time I have here the value of N is 5. Also the value of R is 5. So the value of N and R is the same. So this is also equal to 5 factorial. Again, simplify 5 factorial. We have 5 times 4. Your answer multiply by 3. Your answer multiply by 2 your answer multiplied by 1. Let me see if you get the correct answer. Correct. There are 120 arrangements. Very good. Example letter E. How many arrangements of the letters of the word poetry are possible if they have POE together in any order? So first, I have here an illustration. You can see here that we can only have 1, 2, 3, 4 rows because I write the letter POE together in a 1 row. And you can also see here the word in any order. So this time, the formula is permutation of n and r multiplied by the permutation of n and r. Substitution. First is the value of n and r is 3 because of the letters P, O, E, and the value of the next permutation is 4. As you can see here in our illustration, we now have 4 rows. Simplify, this is 3 factorial times 4 factorial. So 3 factorial is equal to 3 times 2 times 1 multiplied by 4 factorial, which is 4 times 3 times 2 times 1. So this time we have 6 multiplied by 24. So the answer is 144 arrangements. Before I proceed to our last problem, I hope that you still remember our answer in problem example letter A and in our recent example, which is letter E. So how many arrangements of the letters of the word poetry are possible if P, O, and E are not together? So to get our answer, we need to get the total, which is we already got it in problem solving letter A and in our answer in problem solving letter E, because in letter E, we asked to give possible if P, O, and E are together. So this time we need to get if P, O, and E are not together. So let us recall our answers. So for letter A, we have 720 arrangements, or our total, or word restriction. And for letter E, we have here again, they have POE together in any order. So this is somehow opposite to our problem letter F. So the answer is 144 arrangements. So simply subtract 720 to 144. So we have 6 factorial subtracted to 144, and it goes 6 times 5 times 4 times 3 times 2 times 1 is 720 minus 144. The answer is, so what is your answer? Very good. The answer is 576 arrangements. So, for today's discussion, I hope that you learned problem solving involving permutations, linear permutations, and arrangements with restrictions.